Okay, I'm going to pick up in Chapter 7 where we left off. That takes us to Section 7231, and I hope to finish up all of Chapter 7 or the rest of Chapter 7 in this lecture. So this is talking about address types. Really, it's more communication methods. In the case of IP version 4, we had unicast, multicast, and broadcast. In IP version 6, we had some similar things, slightly different. A unicast is exactly the same, and that's what they're showing here in the diagram, as you have one sender and one recipient. We're using IP version 6 addresses, of course, instead of IP version 4 addresses, but unicast is basically the same thing. Also basically the same thing as multicast. In the case of multicast in IP version 6, you have a single packet from a single source going to multiple destinations, which is possibly a subset of the network. IP version 6 has something called an anycast. This is a little bit strange because we're giving the same IP version 6 address to multiple interfaces on multiple devices. And when you send to that anycast address, the closest device with that IP is going to receive the packet. Now notice here it says anycast addresses are beyond the scope of this class. That means they're not discussed in Cisco 1, but they'll be discussed possibly in Cisco 2, 3, and 4. Now, we didn't mention broadcast. In the case of IP version 6, they have something called an all nodes multicast. So if you're multicasting to all nodes on the network, then that's pretty much the exact same thing as a broadcast. So those are the different types of communications or slight changes in terminology that you would need to be aware of when we're talking about IP version 6. In IP version 6, we haven't talked a whole lot about subnetting yet, but you don't really need to subnet, at least not yet, not till we run out of our million, billion IP addresses. But basically what they do is they divide the 124-bit IP version 6 address in the middle, which would make it a /64. It does not have any other representation than that for a subnet mask. So they're showing you an example here of where they have split this. Notice we talked about shortcuts last time. This ends in : : so you just put as many zeros as you need to fill out the 128 bits. Okay, we talked a little bit about how we had public IPs and private IP addresses and special use IP addresses, that type of thing with IP version 4. We're going to talk about the same type of thing here, talking about unicast addresses. So addresses that are going to be globally available for one-to-one communications. We have something called a global unicast. It is a globally unique internet routable IP address. So basically this is like a public IP version 4 address. We have something called a link local address. This is used to communicate with devices that are on the same local link, i.e. the local network, and routers will not route link local addresses. So link local addresses are kind of like normal IP addresses other than the router ignores them. So this is how we're going to communicate on the local area network, is with link local. We talked about the loopback address and localhost. In IP version 4 it is 127.0.0.1. May have mentioned this in passing last lecture, but in IP version 6 it is : : 1. So : : 1 means you put 127 zeros in front of that, and the last bit is 1, and that is the loopback address. : An IP address that's all 0 is similar to 0.0.0.0 in IP version 4. It can represent an unspecified address if we're looking at this in the context of an IP address for a device, or if it's in a routing table, it will refer to the default route. Unique local addresses, these are similar to IP version 4 private addresses that you can use with inside a network that is private. And then an IP version 4 embedded is really beyond the scope of this course, Cisco One, but basically it is an IP version 4 address that the 32 bits of it are encoded as the last 32 bits of an IP version 6 IP address, but that's called IP version 4 embedded. So we'll talk about these in a little more detail. First, talking about the IP version 6 link local, used to communicate with other IP version 6 devices on the same network as I mentioned. It is not routable. That means if this packet is seen by this interface of the router is going to know that it's a link local address and it's just simply going to ignore it. That is, not pass it to, in this case, the other two segments that are shown. Every IP version 6 interface that is enabled will have a link local address. Again, this is kind of similar to how the MAC address is used in IP version 4. If the device does not have one manually configured, then just like IP addresses, it will go to a DHCP server to get that link local address. The other thing to mention is notice that all these start with F8E0. The link local addresses are in the FE80/10 range. Go to figure 2. So basically, I will send routing information to the other router's link local addresses. It sends it there, and then this router is going to send link local information out to the other router, in this case PC on this, and then with that information, host will set the interface closest to them as the default gateway. Okay, 7235 is an activity that you can do on your own to make sure that you understand the mapping between the address type on the left into the boxes on the right to match the description. So you can do that on your own. Okay, so we're talking about global unicast addresses now. Again, these are globally unique and also routed. They are equivalent to IP version 4 public addresses. Currently, the only IP version 6 global unicast address are in the 2000:/3. That means the first 3 bits are the part that is looked at or consistent in this. That means they start with 001, as they show here in the figure. So that's just one little bit of the billions of addresses that are available in IP version 6. If we ever get close to exceeding that, then they will somehow change it so that there are more IP addresses are available. This is about 1/8 of the total IP version 6s that are available. The other thing too, over here you see that 2001:0DB8/32 is reserved for documentation. Can't remember what it was called with IP version 4. I think it was called test IPs, but there was a set of IP version 4 address space that was set aside for examples and documentation, that type of thing. This is the IP version 6 range that is set aside for those exact same purposes. Now then, when you have a global unicast address, there are three parts. The first is the routing prefix. That is what regional internet routers use to route packets that are provided to the customers. The subnet ID is used by an organization to identify subnets at its site. So at UK, a lot of times a subnet will be a particular building. So this could be a building number or something like that. And then the interface ID, which we have 64 bits for, this is exactly equivalent to the host portion of an IP version 6 address. So here they're just showing you a couple of examples, the routing prefix, the subnet ID, and the interface ID, and how that was obtained from the compressed IP version 6 address that we see up here at the top figure. If we have a unicast that we want to hardcode, and we're talking about a router, we have a topology here. Since this router is highlighted, that's what we're dealing with down here in this console window. We have three interfaces that we need to configure correctly. So we first go to gig 00, and here's the subnet number :1. We then go to gig interface 0/1, configure its IP address, and then lastly we go over here to serial 0/0/0 and configure its IP address. Notice that with the interface portion of this, we're in global configuration mode. We go into an interface. Instead of saying IP address like we've seen before, we say IPv6 address. And to bring the interface up, we of course say no shutdown. So very similar to IP version 4, except for those few little different, for obvious reasons, differences. Here we're looking at the IP version 6 properties on a Windows machine. The panel looks looks very similar to what we've seen before. Do we want to get it automatically or dynamically? Do we want to hard code it, a static address? So we've chosen a static address. Here's the IP version 6 address. Its prefix length is /64 divided in the middle, and here's the default gateway. So other than having to do this in IP version 6 addresses and doing a prefix length instead of a subnet mask like we would see in IP version 4. So that's host configuration. In Unix, we have the ifconfig command for interface. It would be ifconfig, the interface name, inet6, and then you would give the IP version 6 IP address / the prefix length. So, that's how we would do it on a Unix machine. This is an activity where you can either do what they ask you to do here in the bolded white text, or you can have it show you step by step, or you can have it show you everything if you have difficulty. So this is an activity that you can do on your own. Okay, dynamic configuration and router solicitation. So what happens is you send out a router solicitation which goes to all IP version 6 routers that it can reach, and it says I need some addressing information. And then the router will come back and to all IP version 6 nodes, it will say here's your prefix length, and here's your default gateway. So this is one way to get the information. Option 2 is to do a combination of the router solicitation but it may say, here's my information, that being the router, but you need to get other information such as DNS address from a DHCP v6 server. Or you can do DHCP version 6 only, which is exactly like DHCP and IP version 4, other than we're dealing, of course, with IP version 6 addresses. So this one basically has an IP address, and what will happen is ICMP will advertise that it needs to know about machines. This machine will reply back and say, here's my statically coded IP address. Dynamic host configuration protocol version 6 is very similar. Basically, the router solicitation will be a message from a device that says, hey, all IP version 6 routers that see this message, I need addressing information from the router. That will come back and say to all IP version 6 nodes, here's your prefix length, but you still need to get information from a DHCP server. So there will be a solicitation made to the DHCP server to get all of the needed information to dynamically set the IP version 6 address. Okay, EUI 64 process. This is extended unique identifier. And basically what it does is it uses the 48-bit Ethernet MAC address. It inserts some information in the middle, and it will create from that an IP address. So let's see here. So what it does is it has the 48-bit device. The first half, of course, is the OUI that we talked about. The remaining 24 is the device identifier, which is set uniquely by the manufacturer that the OUI refers to. You split that MAC address in half. You insert FFFE in the middle of it, and then you flip the U/L bit. And that will designate, that particular bit right here will designate, is the MAC address universally or locally assigned. And when it sets it to 1, it's locally assigned. Then we encode all of our stuff to hexadecimal, and that becomes the IP version 6 address for that device. On a Windows machine, if you say ipconfig, it will give you information that you can use to figure out how that IP6 address came to be. Okay, dynamic link local. After the global unicast address is set, again, which is kind of like the worldwide public IP address, the device will automatically generate its link local address. And what happens is link local is used for devices using the routers as the default gateway and to communicate with other devices on the network, and by routers that are exchanging dynamic routing message. Also, in the routing tables for IP version 6, you have something referred to as the next hop address. So link local starts with FE80/10, like we talked about before, and then it will randomly generate or use the EUI64 process to set the interface ID. So this is showing us a EUI64 generated and a random generated dynamic link local address. and then it's showing that all these used EUI 64. This is on a router, and we're using, instead of show IP interface brief, IPv6 interface brief. So a lot of the commands are exactly the same, we just put v6 on the end of them. You can assign static link local addresses, and this figure shows you how to do that for the 3 interfaces on the router. Okay, how do we verify IP version 6 addresses? If we were in class, I would turn around and say, tell me how we verify IP version 6 addresses. There's a couple of things that can be meant by verifying, but in this case they're saying show the interface brief, and it will go through and you can see that each of these has a link local address and a global IP version 6 address shown. So using the show IP version 6 interface command is one way to do that. If we want to look at route tables, instead of show IP route, it is of course show IP version 6 route. This will show you the information. It's differently formatted, but is this a local connection? Is it directly connected? If we need to get to this network, we're going to do that via the GigaNet 0/0 interface, and that network is directly connected to me. So we have routing tables that can verify our configuration. The other thing that we can mean by verifying addresses, and this is what I typically think about, is using the ping command. So the ping command is exactly the same, with the exception of you put an IP version 6 address here, and the ping command is able to figure out that that's not an IP version 4 address, and it sends the packets. Exclamation points are good from a router. Success rate is 100%. We sent 5 packets, we got 5 back. That means the device that has that IP address is on the network, it's functioning, and it is reachable from R1. So this is an activity that you can go through and do on your own to make sure that you understand those last 3 or 4 commands that we talked about. This packet tracer has you go through and configure IP version 6 addresses on some networking equipment. It's relatively short, it's 3 pages long. I will assign this, so look for it to appear in Blackboard at some point in the future. Okay, multicast addresses. These are similar to IP version 4 multicast. However, there are 2 types. We have assigned multicast and solicited node multicast. Assigned multicast addresses are for predefined groups of devices. So that's very similar to IP version 4 multicast. The assigned multicast are used in context with specific protocols, such as DHCP version 6. And in that case, we have a prefix FF02 ::1 that is a multicast address to all nodes. So that's the one that's very similar to a multicast. And then down here at the bottom, we have an address FF02 ::2. This is an all routers multicast. So you have the capability to send to all the devices on a network or all the routers that are visible on the network. Okay. Solicited node IP version 6 multicast is used to join a multicast group. So what happens is, just like before, we send a message to the solicited node multicast. This machine says it's not for me, it's not for me, but it's for me. So you have some subset of the nodes that are going to receive that message, which again is just like IP version 4. This lab has you looking at IP version 6 addresses, as well as introducing you or refreshing your memory as to what the different ranges are as far as the first sextets in IP address. So I will assign this. It looks like it also has you going onto your PC and seeing if you have IP version 6 configured, and then it has some questions related to compressing and decompressing IP addresses, which we talked about last time and a little bit tonight, and then a couple of reflection questions about IP version 4 and IP version 6. I will assign this, so look for it to appear at some point in the future in Blackboard. This is on configuring IP version 6 addresses. I am not going to currently assign this. At some point in the future, I may assign it for us to do on the NetLab, or maybe I won't assign it at all. So may appear or may not appear. ICMP, Internet Control Message Protocol. We talked about this in IP version 4. There are several things that ICMP can be used for. Not sure why the graphic is not completely there. But common for both ICMP version 4 and version 6, we can use this for host confirmation. That is doing a ping, which is an ICMP echo request. When it makes it to the destination sends back an ICMP echo reply. This is supposed to be an animation. Like I said, I'm not sure why it's not imaging correctly, but it just shows a ping packet, which we've seen before. It is also used for indicating that a destination or a service is unreachable. So when a packet cannot be delivered, we receive an Internet Control Message Protocol message back telling us that. We also talked about time exceeded. So when the time to live reaches 0, notification about that is sent via an ICMP packet, and route redirection. So if a host tries to go through a particular router and the router knows a better way that it should have gone, it will send back a router redirection and says, yeah, instead of talking to me, you'd be better off talking to this other router. Okay, here we have router solicitation and router advertisement. We talked about solicitation before, where you're asking a question. Router as advertisement is periodically routers are going to send out information about routes and information about the network that they are aware of, and the other routers or devices will receive that and figure out what to do with it. It can go through and say, I know your IP version 6 address, what is your MAC address? This is basically ARP, but in IP version 6 it is called neighbor solicitation. So it's trying to find out devices that are connected or that are its neighbors on the network. And then here it's doing a multi-cast ICMP version 6 neighbor solicitation. And so it says, whoever has this IP version 6, will you send me your MAC address? If I don't get a network or a neighbor advertisement back, then I know that my IP version 6 address is unique. So basically it's trying to send something to itself. If another device answers, then that was not a good choice of IP version 6 address for the device to be using. So we talked about testing the local stack. We can do that by pinging the local host. In the case of IP version 4, it is 127.0.0, which is localhost or the loopback address for the machine. If we're testing connectivity on our local network, we can of course ping other hosts if there are any other hosts, but a good test is to ping your default gateway to make sure that the address is valid and that the packet will go from the host all the way to the router setting on the side of your network. So, ping localhost, make sure that works. Ping the local router interface, make sure that works. And then pick an address that's outside your local network. So in this case, 10.0.0.1 is going to send a packet. Possibly first. Let's see where it's going to send it. So it sends it to something off the network. So it goes through the router and then goes to, in this case, 10.0.1.1. It sends an ICMP echo reply back, and from information in that packet, it can get timing information, and since it got the packet back, it knows that the packet traversed the local network, the remote network, made it to the destination host, and then came all the way back. Traceroute is a really handy tool. This is one of those things that nobody thought of for years, and then when they thought of it, it's like, what an incredible idea. So we're sitting on a source computer. We want to know what route a packet is going to take to make it to the destination, or how many hops it's going to go through. So recalling IP version 4, we have time to live, and in IP version 6 we have the same thing, but it's called a hop limit. So I'll talk about it in IP version 4 terminology. So what we do is we send a ping packet, but instead of setting the time to live to 128 or 256, we set the time to live to 1. So that packet will leave the source. When it makes it to a router, the router will decrement the TTL. It will be at 0, so that packet will be returned. And since that packet, that ICMP message that tells us that, came from this router, we can get the router's IP address and its name if it's in DHCP, and we know that's the first router. Now what we do is we send another ICMP packet, this time with the time to live of 2. So it goes through this router that we already know about. It decrements the time to live to 1. It goes to this router, decrements the time to live to be 0, and the packet's returned. We send another packet with a time to live of 3, so that should be what the animation shows us. So TTL of 1. So we go to the first router, time exceeded, that message is sent back to the source, so we know about the first router. Now we send a packet with time to live of 2. Makes it to the second router and is returned. Send the packet out, time to live of 3. Here's the first router, the second router, the third router, time exceeded. Will be sent back to the sender. Next, we send it out with time to live of 4. Router 1, router 2, router 3, and then to the final destination, which will then send the echo reply back. So it can tell us information about the 3 routers and then the host destination that packet made it to. So super, super handy. This is a packet tracer exercise about verifying IP version 4 and IP version 6 addresses. It's relatively short. It's 3 pages. I will assign that at some point in the future. This is a packet tracer on using pinging and traceroute. We may do this later. I know some of the homeworks that I make up, I have you do traceroutes to kind of get an idea of where packets travel. So, I'll either assign that later or not assign it at all, or assign it in a different manner. The next is a lab on testing next network connectivity. This will be the second or third time we would have done this. Also, a lot of times labs are intended to be done in the classroom on physical equipment. This is also rather long. It's 16 pages long. I probably will not assign this at all. This lab is called Mapping the Internet. Basically, it would have you use ping and traceroute to kind of map out some services that you might use from your home. I am not going to assign this one probably ever. We may not have been doing this long enough, but the way you tell you're getting to the end of the chapter is you have a ton of possible assignments. This is troubleshooting IP version 4 and IP version 6 addresses. It is likely that I will not assign this at all, but you probably should at least glance over this lab to see what it's about. I think the activity at the beginning of Chapter 4 was called the Internet of Everything. They're just kind of going back and having you do the same thing now that you know some of the terminology for IP version 6. And then, it has you sharing it with the class, that type of thing. I'm pretty confident I'm not going to assign this ever. Okay, Chapter 6 had a skills integration challenge, which I did assign. I'll look over this a little and decide if I want to assign this for Chapter 7. So either I will not assign it, or I'll assign it down the road. So it may or may not appear in Blackboard. It is super short. Page 1 is a topology, and page 2 is just some default gateway and IP version 4 and IP version 6 completion. So it may get assigned, but we'll see. So that takes us to the summary of Chapter 7, 7413. So this is just kind of refreshing your memory as to some of the things we talked about in Chapter 7. Your Chapter 7 exam, I will activate that in Netacad, and then I will send out an announcement to let you know when it's there and when it's due. And the next lecture will start into Chapter 8, which is entitled Subnetting IP Networks. So we'll get serious about doing some networking math and learning about subnetting, which is a very important thing to know about. That's why they dedicated a whole chapter to it. So we'll call it quits on Chapter 7 and start into Chapter 8 next time.